Welcome. We're going to be working through question 3. Now, question 3 is really quite tricky, so I actually want to go through different ways of approaching it. So in this video, we're going to be going through method 1, and then I'll do another video in which I'll show you another way of working through it, method 2. But this video, method 1. All right, so let's launch into it. Let's give it a read. It says, the network diagram below shows the local road network of town M. The numbers on the edges indicate the maximum number of vehicles per hour that can travel along each road in this network. The arrows represent the permitted direction of travel. The vertices A, B, C, D, and F represent the intersections of the roads. So here we have a flow question. And A is asking us to determine the maximum number of vehicles that can travel from the entrance to the exit per hour. So for part A here, what we want to find is the maximum flow. So this is how I'm going to approach it. Now, this is going to look a little different. So method 1 is a bit strange, but as we're going through it, you're going to see the benefit of method 1. So this is what we would do. I would first say I have 1,500 cars going through this way. Then they split up. 700 are going there and 650 are going there. So if I come to my CAS and I go, well, what's 700 plus 650? You can see that's going to be 1350, which means all of the cars can go through this way. So I can have 700 cars going through that way and 650 cars going through that way because 1350 is less than 1500. All right, let's now just focus on one of these pathways. So let's go 1500, 700, and then from 700, I have 680. Now, this is where you got to be careful. If I can only fit 680 through this way, what's the point of sending 700 down there? I shouldn't send 700 down there because I know that my next road can't cater for it. So this should be 680. I'm doing that in red because this is a restriction. This has to happen. I can't send 700 down that way. Otherwise, there's going to be like a car crash or something. All right, so there we go. So we've gone through that way, then that way. Now we come to a point in which it splits. We've got 620 or 320. So if we kind of look at that and we say, well, can 680 maintain a split of 620 and 320? Well, obviously not. If I have 620 plus 320, that's a total of 940. So if we just come here for a moment, I'm going to write, this is 940 cars going through both of these combined. Well, 680 isn't enough, but let's also remember that I have some cars coming through this way as well. So let us now look at this 300 pathway, which actually means I'm going to have to start from the beginning. I've got 1,500 cars going through this way. Then I have 650 cars going through this way. What happens if I send all 300 up this way now? Well, if I send all 300 up that way, that's pointless because I know that 300 plus 680 is going to be 980, right? So if I come here, 980. 980 is too big. I can only fit 940 through here, which means I shouldn't send 300 here. I should send 40 less. I should send only 260. And the reason for that is because I know I can only fit 940 through these pathways here. So that means now, if I go 680 plus 260, I'm going to get 940. And that means that all of the cars can now go through there and there. Perfect. So again, the reason why I'm doing it in red is because this is a restriction. I can't send 300 up that way. Otherwise, there's going to be a car crash. It doesn't work. I can only send 260 through that way. All right, so now I have 1,500 coming through this way, 650 going through that way. How many cars do I have going through this pathway? Well, if I sent 260 up that way, I'm going to come to my CAS and say, well, I had my 650. Now I'm going to minus 260 from it. That means I only have 390 cars going through here. Now, why am I doing this in green? The reason why I'm doing it in green is because this isn't a restriction in the same sense that these were restrictions. These were in red because I could not fit, 700 through this way because this could only count for 680. And so too here, the same logic applied there. The reason why I'm doing this in green is because I only have 390 cars left once I've sent my 260 here. So I only have 390 cars here. If this number here was a bigger number, if 650 was bigger, then I could fit more cars through here. But at the time being, I can only fit 390 cars here based on the numbers that I currently have. So let's now keep on going through this. If I have 390 coming up this way and 320 coming up that way, how many will go through here? So I'm going to go 320 plus 390. That's going to leave me with 710. So again, the same logic. I only have 710 cars here. I can't put the 840. So 840 is what it can maintain. It can maintain 840 cars. But I only have 390 plus 320 cars to send through. So it's only going to be 710 there. All right, then we keep on going. Now I have the 620 here and the 710 here. So what's 620 plus 710? 620 plus 710. That's going to be 1330, which means, I could fit 1500 through here, but I only have 1330 to go through based on these numbers, which means 1330 for this network right here is my maximum flow. I can only fit 1330 through it. So that right there is going to be my answer. So let's do this in blue. My answer will be 1330. If we look at our examiner's report, you can see that only 24% of the state were able to answer this successfully. The correct answer was 1330. This question was not answered well. Many students did not demonstrate they had tried to find the minimum cut. Now, they're talking about minimum cut there. That's what we're going to go through in our next video. That's going to be our method 2, the minimum cut method. At the moment, let's just stay with our mindset that we're currently on doing it this way, but there is another way to do this. We'll talk about that later. All right, there it is. Let's now go to part B, and you're going to see why we chose to do it in this way. Like, why did we use this strange method 1 here? All right, so let's go through B. B then says, the local council plans to increase the number of vehicles per hour that can travel from the entrance to the exit by increasing the capacity of only one road. Complete the following sentence by filling in the boxes provided. The road that should have its capacity increased is from vertex what to vertex what? All right, so just to summarize this, we want to increase the number of vehicles that can travel through this network by only increasing the capacity of one road. Which road should we increase? Well, looking up here, I really want you to focus on these green numbers here. These green numbers represent kind of underutilized roads. Look at this road right here. This road can have 1,500 cars going through it, but we only have 1,330. We're not using it to its full capacity. So too with this one. So too with this one. Well, how can we use these roads to their full capacity? What we would need to do is we would need to, and let me do this in orange, we would need to increase the capacity of this road. And if I increase the capacity of this road, that means I could send more cars through here. So you're not going to increase the green numbers because the green numbers represent underutilized roads. You want to do something upstream from that. So if I increase this, I'm going to allow more cars to go through this. Because remember, currently, I had 650. Whoa, sorry, I didn't want to type it there. Remember, here I had 650 minus the 260. 650 minus the 260, which meant I could only put in 390 through here. But can you imagine if this was like 1,000? If this was 1,000, and now I take away my 260, well, now I could send 740 through here and use this to its full capacity. So hopefully you can see here just kind of intuitively that A to D is the one that you have to increase. So I'll come here from A to D. And again, I really feel that using this method allows us to kind of identify that very easily because we knew it had to be upstream from the green numbers. All right, if we look here at our examiner's report, you can see that 38% of the state were able to identify that, A to D. So again, people are struggling with these questions. The last one is now really tricky. It says, what should the minimum capacity of this road, let me try this again. What should be the minimum capacity of this road to maximize the flow of vehicles from the entrance to the exit? So in other words, what is the minimum number this could be in order to maximize the amount of cars going through it? So what you might say is, well, how many cars should I increase this so that I can have the 740 cars here? And hopefully you can just immediately see, well, if I increase this to 1,000, and then I minus my 260, well, now that's 740, meaning I've put all 740 cars through here. So that's great. But then I would say, well, 740 plus 320 now. 740 plus 320. That's going to be 1,060. This road right here can only maintain 840. Is there any point, therefore, of sending through 740 cars through here? There is not. There is no point in doing that. I can only increase this road to make it a maximum of 840. Now, you can kind of think through other mathematical ways of how to do this. The easiest way here is just to recognize, oh, I can only increase this by 130. That's it. I can only increase it to 130. Because now, if this is 840, then 840 to 620. So 840 to 620. That means I can send now 1460 through this, and that would be the maximum flow going through it, 1460. But as you can see, I can only get this up to increase it by 130 to 840, which means I should increase which means I should take this 390 number and increase this by 130 as well. And which also means I should take my 650 number and increase this by 130, which would become 780. So now, if I had 780 here, I would go 780 minus 260. That's now going to become 520, because that's 520 if you plus 130 to that. Now I would have 520 plus 320, which is 840. So this means that this has to be 780 there. That has to be 780. And this was kind of the limiting thing here. We had to look there to really figure that out. But again, hopefully you can just get a sense of what we're doing here. If you're given another network, you'd have to think it through in a slightly different way, but all the same method, all the same logic you'd be using here. So my answer is A to D now has to be 780. All right, so we'll come here. 780. We look at our examiner's report. Ooh, where is it? You can see that only 6% of the state were able to do that. That is tricky. That is very tricky stuff. The correct answer was 780. This question was not answered well. All right, so that is one way of doing this question. What we're now going to do is we're going to talk about another way of doing it, which is method 2. So join me in that next video where we talk about another way of doing this.